Got it. Okay, recording. Distance learners that are participating today, you do not have to watch the play pause it on Tuesday because it's going to be this, okay? So don't worry about that. You are taking care of your play pause it that day. Let's go ahead and answer this question here. I'll give you a few minutes to work it in your notes. First, explain why x is a binomial random variable. Find the mean and standard deviation of x. Interpret each value in context. And then C, the store clerk is surprised when 3 of the friends win a prize. Is this group of friends just lucky? Or is the company's 1 and 6 claim inaccurate? Compute it and use the result to justify your answer. So we'll give you a few moments to do that. And then yes, we're going to play our game. How does that look? That's right. Yeah, it's fine. Go ahead and close it. I don't think anything else is coming. Hey, to somebody that's distance learning, do y'all want? Can one of y'all test your if I'd like to ask for some of y'all to speak at some point. Can one of y'all test your audio? Just see if your mic will play through my.
Hi.
Oh, is that Katina?
Yes, sir.
Nice, we can hear you. All right, cool.
I'm so excited about that.
I mean, this is day. I've never done this, so maybe I should.
I don't think they want to.
Well, no, we got. What do we have? 1, 2, 3, 4 people.
Wow.
I'd rather do this because I get bored.
Yeah.
Who else is in the class that didn't join?
Oh, there's 4 on here. We have several distance learners, so I mean, there's people in here that are moved to distance.
I'd rather do this than
You think so?
This
is a lot more work for me, for sure.
Okay.
But I get it. All right, we're gonna go ahead and get started. Those that are distance learners, if you want to answer one of these questions, go ahead and type in chat which one you're interested in answering right now, and I'll consider you to call on you to explain. Okay, we're gonna try to keep it involved. So Cheyenne is interested in the first one. Okay, gotcha. All right, so we need to explain why this is a binomial random variable. So I'm gonna actually sit down in front of this, and I think I'm going to be able to annotate and write on here. Hey, nice. Okay, Cheyenne, do you want to speak on your mic? See if we can hear you.
Yeah.
All right. I don't know if everybody can hear you, but I'll echo what you're saying. Do you want to explain why the binomial random variable, why this is a binomial random variable?
It is because you either win a prize or you don't.
Okay. So what did we use in class to determine binomial settings? Because that you are correct. What's the process that we used?
The I forgot what they're called, like the little tree things.
Not the tree. We used that to display what a binomial, an example, but we had an acronym that we used.
Oh, bins.
Bins. Okay, so everybody should hopefully have written bins for part A. Okay, so say what you said again, Cheyenne.
You either win a prize or you don't.
Right, and which one does that go with?
Binary.
Binary, yes. And they say success or failure. All right, somebody in here want to talk about I? So thanks for getting us started on that, Cheyenne. If you want to mute, you can. CJ.
The chance of winning is independent of 1 in 6.
Okay, what does it mean for, so CJ is saying I means independent. What does it mean for them to be independent? What does that actually mean?
The odds of winning 1 is not affected by previous trials.
Good. That's textbook definition. Knowing what happened before does not affect the future outcomes in this situation with these bottle caps and these bottles of soda. Okay. Somebody explain that.
The set number of trials.
Set number of trials. How many do we have here? 7 friends.
Buy one.
Yes. So 7 friends each buy 1. So your trial, so that's, yes. So N would equal 7, right? Is that correct? Mm-hmm. And then what is S? Yeah, the probability of success, what about it? It is 1 in 6, but there's something special about this, about it. Huh? Every trial, it's the same. Okay, what is that probability? 1 in 6. So 1 out of 6. We are going to need this information for later. Yeah, what's up?
So for I mean, technically it could, like the if someone else buys a different one for you and say only like 6 of them were made and only 1 of them actually got that, like,
So 6 Cokes are made?
yeah, and then like 1 is taken and that's like the winner, so nobody else can win after that.
Interesting.
And so
All right, so let's think about that. So Henry's bringing up a very good point that we actually need to talk about, okay? This idea of independence is if somebody picks that winning Coke, then your probability goes away, right? Like it becomes 0. All right, I'm glad that you said this. Oh, wait. Let's go to this right here. Okay. In your notes, I want you to write down, and I'm gonna erase this because we did this. I'm gonna highlight what I want you to write down. Everybody's gonna do this in their notes. This answers Henry's question. It is a great question, and it's one that I didn't know if we were gonna get to in this section, but since it came up organically, we're gonna write it. So everybody write what's called the 10% condition, okay? And you can just write this rule right here, okay? And I'm going to add a few more things in here. N is your population size. Because you are correct in the fact that if you get the winning one, it is over pretty much, right? We know that, okay? But what this is called the large counts condition, the 10% condition, which is saying that the population is so large. Let's give an example here. Okay, let's say that I'm interested in doing something where I'm going to go through the school, I'm going to pick male or female, okay? And I want to pick 4 female students, okay? And I want to get 4 of them in 10 random selections. Is everybody okay with that? If I pick 1 female, what's the probability of picking a female, by the way? Like in general, what's the ratio of males to females in most populations? 50-50, right? 50-50. If I take 1 female, let's just say it's Mackenzie, does that change the probability that I'm going to pick another female? Okay, but by how much?
Very small amount.
Like how small are we talking? Is it like, would this, do you think, so there's 2,000 students here. If I pick Mackenzie, that is one, and let's say there's 1,000 females. She's one of 1,000. What is that as a decimal? That is 0.001, right? That is 1/1000th, okay? Let's imagine it's for the entire state of Tennessee, or let's say all of America, and I'm doing the same thing, right? 300 million people, 150 million of them are female. If I pick one, does it really change the probability that much? It's still practically 50-50. That's what this rule is saying. If your sample size is small, okay, this is why it's called a 10% condition. If your sample size, which is in here, is less than 10% of your population, it doesn't really change probabilities that much. Now, I get what you're saying. If you win, it is over, but hopefully that makes sense a little bit. Does that kind of make sense?
Well, I assume that since there's so many.
Right. They're like, how many Cokes?
It wouldn't change it that much.
Let's go, yeah, exactly. Let's go back to the example. Okay. How many Coca-Colas do you think, or how many bottles of soda do you think they're making? Millions, right? So if you pick one and it doesn't win, the probability hasn't changed, right? But it said 1 in 6 win. You do still have a lot that are going to win, right? 1 in 6. If they're making 1 million, if they made 6 million sodas that are winners, 1 million of them are winners, right? That's what this is saying. And if I take one of them, there's still 999,999 left. The probability is practically the same, okay? So there's where we get this rule. And we'll bring that up more later. I didn't want to worry about it too much right now, but hopefully everybody at home is understanding that as well. That is a good question. So we've done A, very good. We'll check mark it. We got it. Okay. Let's go to part B. It says find the mean and standard deviation of X. Anybody have that? If anybody at home has it, you can type to me in chat and I'll let you explain. Mean and standard deviation. We know it's a binomial random variable. We just proved it. Evan thinks he's got it. Which you might have the mean. You have standard deviation?
I'm not exactly sure if I did it 100% right.
Okay. All right.
It's still kind of.
We'll give Morgan a shot here on this one. Mean.
Okay, so I did the, okay, I don't know if this is right, binomial Cdf, and then I put it in that.
So you don't actually even have to do that to find the mean. We have our formulas. It was the last thing we wrote down, I think, on Wednesday, right?
Oh.
Mu of X. This is what we need here.
Wait, then what did I do?
You found a probability is what you did. So she did a binomial PDF, CDF. You don't need to do that here. We have our rules for mean and standard deviation. Oops. There they are right there. Find the mean and the standard deviation, which I'm going to let Mackenzie do the standard deviation. But let's go ahead and calculate the N times P. What's N? 7. We already wrote that down. What's P? 1/6. So that's what we need. 7 times 1/6. Those at home, hopefully you have your calculator. 1.16. That's going to be 6 repeating, by the way. But 167. That's fine. So you expect that it's going to take what is this? How do we interpret this? The average amount that you're going to have to buy is just 1. So that's not really that bad on this one. So that should be our mean. Standard deviation, Mackenzie, you got that one, right?
Yeah.
Okay. So the formula, I just showed that. Tell me what you wrote down, because I know it has a square root. So what's in there?
The square root of N times P.
So that's what? Numbers.
7 times 1/6.
Okay.
And then in parentheses 1 minus 1/6.
Okay. Did you get a decimal for that?
Yeah.
What'd you get?
I got 0.99.
0.99. Okay. And this is the spread of the data. This is, you expect it to take so the mean was 1.16, and you expect that it's going to take between, there's the deviation, one above or one below that to get a winning bottle there. Okay. Yeah, go ahead. Yeah, I don't think it does make sense in here because you do need to buy at least one, right? To win. So it's the number who win a prize, the number of friends. You could have nobody win, right? So you expect to have one friend win. Sorry, I've interpreted this variable wrong. You're gonna have one friend win, two friends, or three friends win. This is how many friends are going to win. Okay, so it's not how many bottles it takes, excuse me, I have that flipped. This is how many friends are gonna win if you do this. So you could have 0 win, 1 win, or 2 win. That's usually what's gonna happen, okay, out of 7. All right, now next, so we've got that one. If there's any questions, I've got the chat pulled up here. If y'all need to type to me, I can see it. This isn't Twitch. All right.
Do that, I'd watch.
Twitch stream.
Yeah, I'll watch this.
Okay.
Yeah, Stream Sellers of Catan.
Is that it?
Okay, I won't
Okay.
watch Catan, but.
We wanna watch.
Catan is amazing. Okay.
Or-
All right, here we go. The store clerk is surprised when 3 of the friends win a prize. Is this group of friends just lucky, or is the company's 1 in 6 claim inaccurate? Compute the probability of getting greater than or equal to 3 friends winning. Okay? What is the probability of this happening? So, somebody have this already? You have it?
I got X is greater than or equal to
Just hide
18.
behind the screen.
Yeah, look at these guys. They're in my peripheral. I'm like looking this way. So, okay. So CJ thinks he's got it. CJ, you want to explain?
I did the CDF, 0.096.
All right. So you said it's binomial CDF. How do we know it's CDF?
Because it's from a range of 3 to 7.
Okay, binomial CDF. So those at home, you should hopefully have your calculator on you right now. He said there's a range. So we see this right here. That's telling us there's a range of values. If it was an exact or an equal to symbol, we would use equal to. Binomial CDF, that's menu 55 in the calculator. Go to the CDF. It's gonna actually I have my calculator here. So we'll just do this. Let me erase all this. So I got rid of them. That's all right. So menu 5. We want CDF here. Number of trials, we put in 7. Probability of success, we can put in a fraction here. 1 out of 6, right? What's the lower boundary? It's 3, right? Okay. What's the upper? 7. Yeah, 7 friends. Okay. So there's our probability. Okay. There's our probability. We'll go back to the slide. So I'm actually going to copy that. Put that in here. It's lagging, isn't it? I've actually on that computer, I'm joined into this. I was trying to get this to stream, but I was having issues. So that computer's actually participating in the Zoom meeting. So it's watching this. It was something else to orchestrate this morning. I'll say that. All right, so the binomial CDF is this. Okay, so the clerk was surprised when 3 friends win a prize. Okay, so using this number, why should they not be surprised? What would be just a reason why it's not surprising based on the statistics here, the probability? Huh?
9% chance.
So what is this 9% chance? It's a 9% chance of what here? At least 3 winning. Okay, but how does that, because 3 of their friends won and the clerk was surprised. Okay, what's the probability that less than 3 would win? And I think I'm interpreting this correctly because I think that's what's surprising the clerk is that they actually won. 3 of them won. What did we say the average was? It was 1, right? Okay. And then the deviation was also 1. So we expect 0 to 2 people to win, right? So I actually want to grab my textbook really quick and read what they have, because let me grab my textbook and make sure that I give the correct explanation. I want to make sure that I've got this right. Geometric. 6 wins. It's adding them all up, that's right.
So that means that the total probability of each individual thing is 9%, which means that everything else should be less than.
Well, so everything else would add up to 100%. So
the chance
there's a 90% chance that
less
less than 3 would happen, right?
which is why it's surprising that they're
Mhm.
9%.
Here, we'll read what it says here. It says, because 0.0958 isn't very small probability, the clerk shouldn't be surprised. It is plausible to get 3 or more winners in a sample of 7 bottles by chance. Okay, so that's what they're saying. He was surprised that they had 3 people, but 3 or more is actually a 9% chance of happening, which is pretty big. Okay, we'll talk more about surprising percents later down the road. But if you remember, we talked about standard deviations, right? Usually outside of 2 standard deviations, that is surprising. Okay, but because 3 is within 2 standard deviations, it's not as surprising. Okay, so that's just a binomial distribution. Now we're going to talk about a new type of distribution, and we're going to play a game. And we're going to play this game, and this is actually going to affect distance learners as well, because in this game, you are going to be playing for bonus points on next week's test. You can't lose any. You could not gain any. You also have a chance to gain some. So this game that I have devised, and I found it in the book, but I repurposed it to fit what I wanted. And I would love for somebody, I want to get at least one of you distance learners to do this as well. But we're going to play a game called Lucky Day. All right, so this is how it'll go. We'll get volunteers here in a second for those that would like to do this. And you're going to pick a day. That's part 1. You're going to guess a day of the week. All right. I will generate a random unlucky day. So let me pull up my Inspire here and show this. Let me clear this here. So I have a list typed in here that has every single day. So y'all can check that out there. Every single day is listed in here. So all I'm going to do is I'm going to try random samp. And I'm going to pick one of these days. If the day that you guessed, if this is the day that you guessed, then you lose the game and it's over and all your points are gone. If the day you pick is not this day, then you're going to get half point, okay, for bonus. Now, I'm going to pick a certain amount of players. What you do here, whoever's participating, that's how many points everyone gets. You are deciding that. One person could decide how many points every single student, distance learners in here, and in this class, 7th period is going to do their own thing, their own trials with this. But you guys are responsible for this, everybody that's participating, okay? So that's the rules of the game. Now, you're going to keep playing and adding points. So let's say you have a lucky day. It doesn't match mine. That's a 0.5. You get half a point. You play again. Again, you get another half point. You can keep playing and get I'm saying if you wanted to try to get 20 points, I will honor it.
But once you lose them, you can't gain any back.
So yeah, you're going to repeat this process until you have repeat this process as many times as you want. If the day you picked is the unlucky day, then you lose everything that you've done.
Can we restart afterwards?
Well, you're going to get 5 tries at this in this class. 5 people are going to try this. And we'll say this, because if you feel like I don't want to push my luck anymore, you can stop right there. So let's say you get to 10 points. You're like, I'm cashing out. That's good enough, right? Or you can keep going.
So you can't get it.
Okay.
So you're telling me
What?
you have a 1 in 7 chance to get something right, but like we have a 6 in 7 chance to just get nothing.
No. 6 in 7 chance to get the point. You have a 1 in 7 chance of messing it up.
Okay, so we're picking
One day.
We want everything else beside this.
You pick a day. If your day that you choose is what I get, your game is over. All your points are gone. Next person. So this is a gamble, right? You are pressing your luck. Okay. Now, those distance learners, I would like at least one of you to do this to get you guys involved. So if there's multiple of you that want to do it, I'll pick somebody randomly. Okay. Now listen up. The highest score achieved will represent the bonus points given to all students. So if you get to 8, you're like, okay, I'm going to back out and then let the next person go. They can try to beat that. 8 is the number to beat. Okay.
So highest score, so somebody said something like, I want to bet like 15.
You're not betting anything. You're just playing until you're done. You can gain as many points as you want, but as soon as you guess the wrong day, it's done. Like you lose everything and it's
What if
over.
I just say I want to get 100 points on this? and then
No,
win?
you gain half a point at a time.
I thought you said, I swear I
Lord
thought
have
you
mercy.
said-
All right, Katina wants to do it. Yes.
Only the ones participating, right?
No, this is for every, you are in control of everyone's points.
But you said you're only thinking like 5, right?
Yes. So here's the question. We're going to do it. Katina wants to do it as well. So she'll be our distance learning person. We'll get her in there in a second, but I want somebody in here to go first. Is anybody interested?
Wait, so I got a question.
Oh my gosh.
If we managed to get 100 points, can we just?
Wesley's going first.
All right, Wesley, you got this.
All right, Wesley. Wesley's going to pick the day, and I'm going to write tally marks. Go ahead, Wes.
Dude, Monday's always a bad day.
He says Sunday.
Yeah.
I like that.
It's Thursday. Okay. All right. You now have half a point. Go ahead. Go again. I've got it.
Sunday one more time.
Okay. That's 2 correct. Go ahead.
Now I'm gonna go with Thursday.
He said Thursday. Okay. Go ahead.
I'm so excited.
Monday.
Okay. Go ahead.
Dude, the only
He said Monday. He's saying Friday. Okay.
You better quit.
You can back out anytime you want.
Saturday.
Okay. He said Saturday. You got Monday. Okay. Go ahead.
Wednesday.
Wednesday. Okay.
What do we got?
We have 7 successes so far.
Take it and run. Take it and run.
She's saying, get out now. You're gonna press your luck.
We got 4 more tries after.
You gonna press your luck?
Yeah, I'll keep trying.
All right. What's the day?
Monday.
Monday. Okay. Go ahead.
Sunday.
Sunday. They're done. You get nothing, sir. You get nothing, sir. Oh man, that's exciting, isn't it?
Oh my God.
Wow.
All right, Katina, do you want to go next? Or you want me to do one more in person?
Do one more because I'm nervous.
All right, she's nervous. She wants somebody else to go. Who's got it? George, you're doing it? All right, my heart's beating. Woo. George, go. Come on, George.
Saturday.
Saturday. Okay, that's 1 success. Go ahead.
Sunday.
Monday.
Monday. Okay. Go ahead.
Thursday.
Thursday. Okay. Go ahead.
Saturday.
Saturday. Okay. All right. So what's your next one?
Let's go with Tuesday.
Tuesday. That's it. He's done.
I felt so confident.
Woo! I'm not going to give any bonus points. This is great.
The house is back.
Oh my goodness.
In theory, what? So I think we should pick the same day and just stick with that.
Yeah, but-
Keep saying-
Okay. Okay.
But you
It's got the
can't.
same, it's got the
Wait,
same.
how many times we got?
You can go as much as you want.
Oh, I thought you said we only.
You never have to stop. Somebody's calling me. Hold on.
Yeah, but I think only 5 people get to
Wednesday's the
try.
holiday.
I think only 5 people get to try.
Oh.
All right, Katina, are you ready?
Yeah, I'm ready, but can you make everyone
All right.
promise to not hate me?
What is it?
Can you make everyone promise not to hate me if I lose all the points?
Well, I mean, they already hate the other guys, so
Oh, no. Okay.
it's not you. No, they promise. Here we go. Katina, we speak loud. We can hear you.
Okay. Tuesday.
Tuesday. All right, there's one.
Thursday.
Thursday. Okay, there's two.
Tuesday again.
Tuesday again. Okay.
Friday.
Friday. Okay.
Sunday.
Sunday. She said
No.
Sunday. That's okay. That's okay. Two more people. Thank you, Katina. Good try. Good try. Who's going?
Seven. We can stop and then we can have the fourth person to try to go for 20, right?
Does that work? Can we do that?
Yeah. Yeah, you can stop at any point. You're saying, I want to leave with what I have.
I'll go.
Okay, Evan is gonna go. All right, Evan. Go ahead.
Thursday.
Okay, he said Thursday. All right. Go ahead, Evan.
Saturday.
Saturday.
Survey.
All right, y'all are at 1 point now. Go ahead.
Tuesday.
Tuesday. You have a 6 out of 7 chance to not do this. Do y'all feel scammed? I mean, I'm giving y'all good odds here. What do you?
Yeah, take Carter.
All right, Carter's gonna go. This is the last person. We've been through 4 people at this point.
Yeah. I think it's
No.
on the day that like just came.
This is random.
I
They're
know
picked.
it's random, but like
Cause it'll do it twice.
I know it's done it twice. but
All right.
It hasn't done it
All right.
twice in a minute.
Just the stress you're putting in.
Is this stressful?
Yes.
Yeah.
You,
I'm not going, I don't want.
Can I pick a German day? That's not
are you ready? All right, Carter's going. Here we go, Carter.
Wednesday.
Wednesday. Okay. Go ahead.
Wednesday.
Wednesday. Go ahead.
Wednesday.
He's going Wednesday. He's going to stick with Wednesday. He's at 3 successes. Go ahead.
Wednesday.
Okay. 2 points right now.
Wednesday.
He's going again. Wednesday. All right. Go. Wednesday again. All right. We have a total of 6 points combined right now. 6 success, or a total of 3. Sorry, total of 3. 6 successes. All right. What do you got?
Wednesday.
He's going again. Wednesday. He's pressing his luck.
Seen it in there also.
Go ahead. I mean, is it in there? Hold on.
Wednesday.
It's right here. It's right there. But you're right. It hasn't shown up.
It hasn't. We haven't seen it a single time.
All right. Go ahead.
Wednesday. How many times am I?
You have 8 successes. So
Keep it going. Keep it going.
No.
I'm gonna just go to 5.
Yeah, yeah.
Let's go to
leave it
5.
there.
All right. Wednesday.
Wednesday again. We have a comment that says we should stop if there's 5.
Yeah.
5
that's
right. Okay, 5 points is what.
what.
So he needs 1 more to get 5 bonus points on this next test. Is this going to be? You doing it again?
Yeah. Wednesday. Like, it's nothing. So let's try to keep going. Wait. If it hasn't shown up a single time. It hasn't showed up a single time though.
Play the game.
Yeah.
And somebody else keeps going to Wednesday.
I'm not against it.
I think we should keep going.
Hey, so
All right, they're thinking.
here's the thing. We
I think
keep going or we can stop.
Look, it hasn't shown up a single time. So.
It's so weird.
Next time, we lose our, no, we need points. I need points.
If we stop there.
Guys, and I'm not there. Listen, there will be no mercy. I agreed to this, and I don't know why Wednesday hasn't shown up. So I will respect the outcome of this. Okay. But listen up. As soon as it does happen, I will not show any mercy. It goes back to 0, and that's it.
If
You
we
get
stop
nothing.
here and somebody else starts, will that?
No. They will have to then go and set the new record.
But here's the thing, guys. We're falling for the fallacy of believing that because we haven't seen it, it's not possible. Well, but how many trials has it been? We haven't got it once.
You can keep going till, I don't care. Oh, this is 10. He's done 10.
No, overall.
Oh, I don't know about that.
Like,
I mean, there's a lot, right?
I know it's been quite a bit.
so what are the chances that we haven't gotten it once?
Opinions, distance learners. This is stressful. They need advice.
So I feel like it's not gonna show up at all. How about it just keep going?
I think you should just lie.
He's going. Oh, I'm excited. Let's go. He's going Wednesday. That's so bad. Oh my gosh.
No, I didn't want that. I didn't agree to that. I didn't agree to that.
I think we need to take it out from outside.
I think
I can't. That's so perfect.
He likes that first. He lost it all.
I'm so sorry. I love it when stuff like this happens. Oh man.
I think we should live stream this.
Carter's not doing the next thing that wins his points.
I got further than anybody else.
It is fair. All right, there's a quote on here. This is fair but unfair. No, it's totally fair. I thought it was bugged for a minute because Wednesday wasn't showing up. But I told you I laid it out plain and Carter pressed his luck. Lesson time. All right, please write this in your notes.
You should have calculated the chance of not getting it.
Please write what's on the board in your notes.
Yeah, now we have to do a lesson.
This is the first year I've ever played this and it was better than I ever imagined it would be. Oh. No bonus points. That's I'll tell 7th it's on them now. All right, and they'll do it
I think
Tuesday.
we should get there.
Wait, what other class
We'll give-
have done this so far?
This is it. This is it. This is the first class. I only have 2 classes.
I didn't know how many.
I'll tell Jack. Tell him to,
The distance learners are devastated
that's their fault.
and they said y'all are lucky they're not here.
We need to calculate
Oh,
the
the shade,
chances of
I'm
not
just
getting
kidding. I'm
it.
just kidding. I'm kidding. I was paraphrasing. They were nice.
Does it have to do like the order you put them?
Holy cow. Oh man.
Constructive
We should blame it on
criticism.
anyone. We should blame it on Katina, right?
No, we won't blame Katina
I think we should
because
blame Katina.
you know,
Henry.
uh-oh.
She ended up herself. I wasn't even the one that.
When should you have stopped? Okay.
5 points is pretty good though.
That was pretty good.
Yeah.
Hey, and you just used what you knew. You knew the history, right?
Yeah.
But Evan even quoted it's a gambler's fallacy, right?
You know what?
Oh, and it's so poetic. It happened immediately after all that debate. Oh, it's
Yeah.
so
But
great.
at least we didn't get negative.
So
points, you know what
poetic.
I mean?
That's why I don't gamble, y'all, right there. That's actually why I don't gamble.
Yeah, like it would have been like so many trials and we had
Yeah.
it once.
No, you're right.
What are
Man.
the chances?
Yeah, we could have just said,
Like,
we could have just stuck with Wednesday.
Yeah.
You should have just not said
We
it.
definitely would have got
I know, if
that.
we wouldn't have had this big debate, it probably wouldn't have shown.
All right. I need everybody to do this. You are going to draw a table in your notes. We are going to make a
Never, you should just never play this game.
We're going to make one of these, a probability distribution. Okay. So we're interested in answering the question, when should you stop playing the game? Okay. Now, you want to stop playing the game before what happens?
We get Wednesday.
Before you get the unlucky day. Okay, when could you get the unlucky day?
Any.
I think you should.
So let's actually define our random variable first.
You should have done it out of months.
And we're going to say, here, let's put this here. Number of trials until unlucky day. That's what's going in there. Number of trials until the unlucky day. That's what we want to figure out, because there is probabilities behind this. There is an answer to this question. And y'all passed that threshold a couple times, and I was like, it's going to happen any moment now. I did design this game, and the same thing would happen at a casino if I built the casino game, right? Okay, they're gonna have fun for a little bit, and then all of a sudden their hopes and dreams will be thrashed and they'll lose everything. You had fun, good. You didn't lose any money, right? So you're good. You don't leave here
That's the
really
problem.
having lost anything.
I mean, next year what you should do.
That's like the same thing with
You should,
like.
like prank them, be like, okay, so if you keep going and you lose that many number of points.
You get.
Well, you don't actually do it. You know what I'm saying?
All right, so number of trials until the unlucky day. Okay, so what's the lowest number here? Well, is that right? Because we're counting trials, right? It's 1, right? You have to at least play, oh snap. Oh. Okay, that's good, okay. You have to at least play once for this event to happen. So there's a 1 here. Okay, so what's the probability that it would happen on the first trial? We should know this. 1 out of 7, yeah, that should make sense, right? Okay, then what could happen? Well, you could have 2, right? It could have happened on the second trial. What's the probability that happens? Well, no, that means you have to have made it 2 trials in order to have a failure on this. Does that make sense? You played the first one and you were good, right? And then you get to the second one and that's when it happens. Okay? Does that make sense?
Yeah.
You've played the game twice, and I want to know what's the probability on the second time you play that you're going to hit the unlucky day. So you already played it once, and you were okay. Huh?
It's the same probability.
But I thought they were independent.
They are independent. So let's think about it like a tree diagram. You are going to be happy, or you're going to be sad. Okay. This is 1 out of 17. So where on this tree diagram that we see here would this event happen? Right there. On the top or the bottom?
On the top.
Top, okay. And then which direction?
Top again.
Happy? Yes, it's this one. So this is 6, 7 here. And then this one here is, well, which one do we want? We want this one, right?
12 out of 14.
Remember, so this is the pathing we want here for this. So we want this event. So we're following this branch here, right? For this one. So that's 6 sevenths. I'm actually going to write this in here. It's going to get kind of cramped, but I'll put 6 out of 7. You'll write this in your table times 1 out of 7. Okay. Now, we do this for the third one. I'll leave myself some space. All right. What's this one going to be? Yes. So I'll change color here. We'll go purple. This would be success, right? Success. And then a failure. And you think the tree diagram helps display this, but what we have here is not a binomial setting. This is not a binomial random variable, okay? The chances keep getting lower and lower. Mm-hmm. It's okay, I'm a sneaky teacher.
Wow, okay.
Sneaky.
Does that mean you put our grades in wrong?
But then also.
No, I don't make mistakes. I'm sneaky, but I don't make mistakes, right?
Well, it's not a mistake.
All right, so what's this gonna be in the fourth one? Let's make a power here. Let's shorthand this by using powers. So 6 to the 6 over 7 to what power? To the third times 1/7. Sorry, distance learners, this is getting cramped here. And I guess you guys can see it too. So. Okay, so we're starting to create these probabilities, okay? And it would continue. When does this chart stop?
Oh, it doesn't start.
Dot, 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 dot. It never stops as long as, until you fail, okay? So what we have here, and I need to take a screenshot of this in case I need to refer to it again, so give me 1 second. This is not a binomial distribution. Did that save the screen? It did. Sorry if I'm freaking some people out with this. There we go. Okay. I'm going to, hopefully everybody has what they need written here. What we have here is called a geometric random variable. Okay, this is a geometric setting. I'm going to erase all this. And you are going to write the yellow. And you're going to also make sure that you write the word geometric setting and the definition. So you're going to write the yellow here. Now, normally on play pause it, I would pause it, but you guys are live right now. Real time. I know, yeah.
You can't speed it up.
I mean, they could just sit there.
So that's what I like about recording and putting on play pause it. I can make these lessons shorter minute-wise, right?
But then they could just skip it or put it on 2 times speed.
No, I need to slow you down.
Yeah.
Oh, there's also.
I actually did that one time because he was talking really fast.
There's a 0.5 speed.
Like one time you were talking really fast.
See?
I guess you had a lot to cover or something.
Probably.
You were getting it. You were scooting.
Huh?
Can you ever get excited about what you're talking about?
Yes.
Or anytime we have to put anything in.
I think I put it on like
I'll have to
20.
pause you and come back like 3 times because I lose you every time.
Yeah. What do you got, Evan?
Is that the same formula we would use for another geometric system? Because it seemed like what the equation was the chance of winning raised to like trials minus 1 times the chance of losing.
You're right on top of it, dude. It's always the same.
That's always the same.
And we're about to write that formula down. Okay. And it's actually in your AP formula sheet. So when we're looking at a geometric setting, it's when we do independent trials, same chance process, and record the number of trials it takes to get 1 success. And then it's the likelihood of getting a success. And we should put these success in quotations here because was our table, our success was the unlucky day, which, you know, that's not really a success in y'all's mind, right? But for me, when I was constructing the game, I wanted to know how many points y'all could win. Because I could have made it 1 point per right answer. I decided that level. And I decided how much I was comfortable with. So we're going to talk about how much you should expect in a second.
Yeah, because if you put 1, then we would have quit.
Right, exactly. I wanted you to, I found like the sweet spot of, you know, you didn't want to finish, you didn't want to end too quick, but you wanted to press your luck long enough to fail.
Kind of like slot machines.
Exactly.
Perfect amount.
It is. And maybe I didn't find the perfect number. Maybe it should have been another amount. But all of that matters and all that goes into creating these kinds of games. Everybody got what they need here? Here is the formula. There it is up top. So you're going to write this formula. And this is exactly what Evan was saying. Okay, that one right there. The probability of an event happening. So you could find the probabilities of getting what is your desired point amount? Like how far would have been enough for you guys? Yeah, 5 points. Okay.
Yeah.
So what's the probability? How many trials would you need to successfully do to get 5 points? 10. So the first failure would have been the 11th. So if we want to use this formula, we'll put 1 minus 1/6 or 1/7 to the K is your successes. You needed 10 successes, right? Minus 1, and then you put it to the 1/6. That tells you the probability of that actually happening, which you made it to it. And we're going to actually figure that out on here. Is it a small probability that it would happen? Yeah, let's look at that. Let me pull this up. So we said it was 1 minus on our calculator. And if y'all want to do this with me here, you make a fraction, 1/6. Raise that to it's K minus 1. So we wanted It would be 11 minus 1, so 10, right?
In the class, you can tell us how you did that. I don't play with my dad. But with my-
Sure. I think y'all's calculators can't do, oh, with money, you're gonna try to get them?
Yeah.
I didn't gain any money.
Yeah, but I can be like, hey, you give me a penny. If you win,
Oh.
I'll give you a quarter.
So you'll know when to stop, right?
Yeah.
Okay, gotcha. All right, so this should be the probability here. Let me make that a decimal. To make it a decimal, we'll just add a decimal right here.
Isn't it 1/7 instead of 1?
It is 1/7, you're right. Thank you. I need to change that. There it is. So you had a 3% chance of getting 5 points is basically what this is saying. That your first failure would be what happened, right? Okay, that's the probability that you would make it that far, okay? Because it should happen before then. You should have failed really before. Feel different.
It'd be interesting to see like what would the percentage be, like if we could see the percentages and what percentage would be top and how many.
Oh, don't worry, we're gonna do that. But we are going to find the fast way to do this. We have in our calculators, we have geometric probability. So you're gonna write these things that I'm circling here. Calculator, menu 55. I actually need to type some in this. Let me back out real quick. I'll make this bigger again. This is exact. Sorry, distance learners, I'll make this larger again. This is the cumulative range at most, at least. All right, I'm gonna make this large again. Okay, so you need to write geometric PDF, which is going to be the exact, and then geometric CDF, which is that same idea as binomial for cumulative, okay? And remember, geometric is saying the number of trials until, in this case, you would get the unlucky day. That's what we're looking at. That is our, quote, success, okay? What, CDF? C is cumulative. So D, a density function. And density, when we think of density, it's area, like area under the curve or the distribution. It's the area of the distribution. So I'm trying to decide what I want to do first here. I think we will use this, new formula here to answer some questions. But I'll make sure everybody's got what they need written here. The wait time. You think you got it, Mackenzie? No, no problem, no problem. Not too much time left here. I wanted to do some of the Delta math problems, so I want to make, hopefully we can get to that. But
That's all due tonight, right?
no, it's I actually moved to next Wednesday. Yeah.
Good.
I finished the 8s. That's the 2 first.
Yeah, the 2 first ones. Ready? Okay. So I'm going to go back to the other, we're going to go back to this blank page. And we're going to ask some questions about this situation. So first off, I want to ask this question. What's the probability? Let's say that you wanted to get 10 points. So what's the probability that the first failure would be the 21st time? Okay. For this situation, remember X is the number of trials. So you already have all this. I'm just going to retype it and reset my scene. Number until unlucky day. Okay. So what we would want to do is, if we want to find what's the probability that this happens, that you would get 10 points playing this game, you'd need to at least make 20 successes here. And what's the likelihood that you would go that far without failing? So in your calculator, let's go ahead and press menu. I'll go slow. Menu 5, 5, so distributions. And then we're looking for what here? Geometric PDF. So it's all the way down there. So H. Pretty simple type-ins here, right? So we put the probability of success. What is success in this case?
6.
Well, we've defined it differently. It's the unlucky day. So this is a weird scenario where what seems like success to you guys, the way I designed it for me was I wanted to know the likelihood of getting this far until this is the first time you get the unlucky day. So we're going to put 1 out of 7 in here, right? Because that's what could go wrong. And what's the probability that you make it all the way to the 21st trial, and that's the first time that you have a failure or that unlucky day? It okay? Yeah. What this is saying is you're supposed to have failed before you got here, basically. Okay? You're not supposed to get this far. So as a teacher, it would be unbelievable if y'all got 10 points from this game. Like that.
Do it the way where you like put the fraction in and put it to the 20th power.
I was doing it, then you started doing that.
Couldn't you do
Yeah,
that?
you could do that actually. And back in the day, that would be the way. Does that work? Let's test it. Does it work? Well, I'm just saying this is, they didn't have the inspires to do this for them. You're saying that didn't work? It would be 6 out of 7, right?
Yeah.
Raise it to the 20th power times 1 out of 7.
Yeah.
Oops. Make it a decimal. I got it. Worked. Yeah, so that does work too. But we have this geometric PDF, so that proves it right there that this does work, and that's what we would be doing. Okay. So we can answer any question like this. So let's answer this question. What's the probability that you are going to fail? Go back. It's being a little glitchy here. What's the probability that you fail before you get to the, what did y'all want? 11, right? Let's see that. Y'all wanted 5 points, but what's probably you would fail before that happened? Okay. So what are we going to type in for this? You go menu 5, 5. Because this is cumulative, so you don't want to use that formula anymore because that finds exact, right? This is all of them combined, right? So this is menu, my mouse work, menu 5, 5. You want geometric CDF. Now, what's the probability? It's still 1/7. What's my lower boundary here? It's 1. It's not 0, it's 1. What's the upper boundary? 11. So this is, you're going to fail either on the first trial up to the 11th trial.
Oh, yeah.
Okay. What's the probability that that was supposed to happen? So me seeing this, I was like, okay, 81% chance of getting this far. I like those odds. I'll take those any day. Okay. So as much as much as you feel like, oh, I have a really good odds at winning this game, this is really your odds of getting to those desired point levels, okay? All right. We have a way of determining a binomial setting. So we're gonna write this down. Last time it was bins. This time it is called bits. So write that down. Bits and bins. So part of your test next week is going to be, you're going to have to determine first, is it binomial or is it geometric? And then you need to use the appropriate calculation on it, okay? So here's how we decide this. Everything is exact same, so it's binary, independent, except the t. The t is different. You count trials until, and here's what's important, and I would underline the word first. And I'm going to put quotations around the word success, because that didn't seem like a success in this case. But the most important part is the word first. Binomial, it's set number of trials, right? That's the difference. That's the only difference. I give you a set number of trials. So if I said, hey, class, you're going to play this 10 times. How many ever points you get within that range, that's what you get. And I don't know if that would be any, I think that would be worse for you if we did that. Maybe not. Actually, that might be okay. Might be worse for me. I haven't thought about it that much. I will later though. All right. Lastly, it's still the same. Probability of success remains the same. So you always had a 1 in 7 chances of getting the unlucky day. I want bits and now bins, or bins and now bits. Is the difference here. I want to look at what this distribution, I want to look at it, because remember with the binomial, we had my little board, right, with the beads. It was symmetric, and then we saw what happened when you changed it and it was skewed. What is going to happen here? We already kind of saw it, right? What's happening as we continue? They're getting smaller. So let's do this in our calculator. I need to erase all this. Let's go in our calculator. Everybody open up a brand new, and I don't have much time here, and I didn't get to even answer the question I wanted yet. Hopefully we'll be able to. New document. Let's open up a list and spreadsheet in our calculator, and let's name it X and PX. Okay. And let's list out, let's actually start with 1, 2, 3, and 4, okay? In here. Now, once everybody has that, let's go in our gray space up there, and we want to type in our probability equation. Okay, so let's do that. First, it's that 6 out of 7, and we raise that to what power? It should be X minus 1, okay? So that's from what we just wrote down in our notes. We're going to multiply that by what? Well, just 1 out of 7, right? Yeah, that's the probability of, and this goes back to what we created in our chart. Go ahead and hit enter once you do that. Or does this raise to power? No, it's not. Make sure you use variable reference. And there's our probabilities. Now you'll notice, I would like you, any questions about that? Right, got it? Here's what's in there if you want to look at it again. Hope everybody's doing okay at home. You can't rewind. Yes, you can, Evan, you're right. So I want everybody to do this. Once you got this, go ahead and type the number 5 in here. You'll notice it just starts auto-generating them for you, live.
Live.
Yeah.
I really like that.
We're doing it live. All right. Let's go ahead and plot it and see what it looks like. Menu. Statistics. No, sorry, data. Summary plot. New page. X and PX. we get this. And if you want, you can go back in here and start adding more numbers. And it never stops. I'll go all the way to 20 here. You got 30, okay? So it just keeps going and getting smaller and smaller and smaller. So if you want to go back to your graph, you can hit menu, zoom data. There it is. There's 20, right? So if we have to look at this and we say, what is the center of this data? That's my question. Where's the balancing point? Where's the mean? Where is the center of this? Where does it happen? Where's that point? If it's made of a solid material, where is it balanced? Where you can put your finger. Where? Is it 3? Here's 3, right? Do you think it would still tip over?
Mine's just highlighted, I don't know why.
All right. Where is that, right? Because at that point is where you should stop playing the game, right? Once you reach that center, that is what we call the expected value, the mean, right? Let's write this down in our notes. One last thing, and then we're going to have to get out of here. Right there, highlighted yellow, and this is the final note. The expected value for a geometric random variable, this is on y'all's AP formula sheet. It's a very simple formula. 1 divided by P. So really this is telling us, when did I expect you guys to actually fail at this? This is what it's saying. When did I know that this game should have ended? All right, the amount of points you should have stopped at. Well, you do 1 divided by the probability of success. So let's do that. I'm going to go back. Last thing. Sorry. Let's go back up here. Calculate the expected value. This is actually going to answer the question that I have here. PowerPoint is actually crazy. All right. So we write this in here. What is the expected outcome for X? Well, how do we do that? It's 1 over P. What is probability here? 1 over what? 1/7. What's 1 divided by 1/7? 7. This is when you guys should have stopped. Once you got 7 successes, you should have stopped. This is what is expected. This is the expected amount of trials to get my first unlucky day, which means I expected you to get 3.5 points. I think it's right, or 3.
I'm pretty sure we stopped at exactly that. We were like,
Well, he had 10 and y'all were debating it, so that was a miracle, right? Okay. All right, that's going to conclude this lesson. Distance learners, thank you so much for checking in. That was fun. You do not have to watch this lesson on Tuesday. This is what's going up there on Tuesday. So you're already clear on that. Have a great weekend. Enjoy your 3 days. If you have questions, email me. Bye-bye.